Hello friends. Uh, today's session today's session we are going to start with the enumeration, autoboxing, annotation, practical. That is practical part 1 we are going to cover. Okay. So some programs are there we have already seen in your theory part. So we will be viewing all them one by one. First was enum demo. So same example I have used that was so you no need to go back it. You can go back to your theory video. My theory video in the theory part, enumeration, autoboxing, annotation, and the details of output, how we are going to produce output over here. Okay. So first example we seen was enum demo. One Apple enum we were created. These were constants: Jonathan, Goldendale, Reddale, Winesap, and Courtland. Okay, so here we have created the object of this enumeration in a apple. Then apple is initialized with Reddale, and then we are displaying the value of AP. Then apple is initialized with apple.goldendale, and then compared to enum values, if apple.goldendale is equal to AP, then app contains Goldendale. And also we have switched with the values. AP is now initialized with Goldendale, apple.goldendale. So it will be directly switching to the Goldendale element constant, and it will display Golden Delicious is yellow. Okay. And then it will break out of the control statement. Now we will run this project. Value of AP is first of all we initialize with Reddale. Second, it was initialized with Goldendale, and third, Golden Delicious is yellow. Okay, so this was the first example we were seen. Now we will close this project. Now we will see the second example, enum demo 2. First of all, we will run this. Okay, Jonathan, Golden, Reddale. So iterating through the enum. This is the enum, same enum we have created. Then apple object. Here are all apple constants. Apple dot values will be stored over here in the array, and we will iterate through the array to display all the constants. For apple A colon all apples, this is the array, this is the variable through which we will iterate. Then value of method, apple dot value of winsap, and it will be used to initialize the AP, and now AP will contain the winsap. Okay, so this is the output from this enum demo 2. Now I will close this project. This is the third example of enum demo. Okay, with the initialized values. First of all, we created these enums with values. Then this is the parameterized constructor, and get price to return the price of particular constant. Here apple object is created. Every apple cost is displayed using apple dot constant name dot get price method, and in cents it is going to display. Now we will display using variable A all apple values. It will give you the values of all apples like we have seen in the previous example, and it will give you the cost and get price in cents. So now we will run this. Winesap cost 15 cents because in the bracket we have specified the 15 value. Then all apple prices from Jonathan 10, 9, 12, 15 and 8 cents. Okay, so this is the way we will initialize the price of the particular constant. And how to give it using the parameterized constructors. Whenever this constant is created, this parameterized constructor will be called, and this price will be initialized. Its price will be initialized with P. So no need to use set price. This parameterized constructor will do the work, and get price will return the particular price of constant. Now we will see the fourth example of enum. Okay, here I have not specified the rate value. For that, I have specified the default constructor. So default constructor have the value price is equal to -1. So in this case, the same example as previous example, enum demo 3 is used. Only thing I have changed over here is apple initialized with price is equal to -1. So when I call this one, red del price will be initialized with the -1 value. Now, WineSap cost 15 cents will be same, and all apple prices we will be having value of the red del is equal to -1. All apple prices, Jonathan 10 cents, golden del 9 cents, red del cost -1. Because I have not initialized with any value. I have not given any opening and closing parenthesis. In that case, I am not giving value. In that case, the default constructor will be called and its price will be initialized with the -1 value. Okay. You can go through this program. The program is same as we have seen in the theory part. Now we will see enum demo 5. In this enum demo 5, ordinal, that is the index value of particular constant we are gathering over here. Here also same enum is created. All apple constant and their ordinal values we are going to display. For all particular values, we have using this method a dot ordinal. Okay. Then AP is initialized to red del, AP2 is initialized to golden del, AP3 is equal to red del again. So red del will be having constant value index of the red del. So what is this? 0, 1, 2. So red del's value index will be 2. Here also it is 2. For golden del it is 1. For red del is equal to again 2. Okay. So now we will comparing the value. If AP dot compare to AP2, so red del is coming before golden del. No, golden del is coming before red del. So it will give me the false. It will not be printed. If AP dot compare to AP2 greater than 0, yes, golden del comes before the red del. So it will give me, it will display this message. And if AP dot compare to AP3 is equal to 0, means both are equal. Red del index and red del index, AP and AP3 both are same. So in this case, it will display this message. Okay. Also, other than this way, we can display the message using AP dot equals method. If AP dot equals AP2, no, it is not equal because one is red del, another is golden del. If AP equals AP3, yes, AP equals AP3. Okay. And other third way to check the equality is AP is equal to AP3. Okay. So now we will run this program. all constants and their ordinal values, that is index. Jonathan index is 0, Golden Dale is 1, Red Dale is 2, Winesap is 3, Portland is 4. Okay, Golden Dale comes before Red Dale. Red Dale equals Red Dale, Red Dale equals Red Dale, and Red Dale is equal to Red Dale. So three are giving us same message, but only way to check the equality is different. First way is what? Using is equal to 0 compared to method. Okay, if ap dot compare to ap3 is equal to 0, this is the first way to check the equality of the ordinal values of the enums. Then ap dot equals ap2, ap dot equals ap3 is the method equals method, and third one is ap is equal to ap3. Okay, so you can go through this program. Okay, so now we will go through the enum demo next. We will see the question answer example we have seen in the previous sessions. Ask me, use it, enum. For that I have imported the random java.util.random class. This is the enum answers. Okay, enum is the best way to declare. In the previous example, we were having the final keyword to initialize all this value. Final integer no is equal to 0, final integer yes is equal to 1, and so on. Now we are having enum for that. By default, they will be initialized with the indexes, like no will be initialized to 0, yes will be initialized to 1, maybe it will be initialized to 2, and like that. Now, question is created first. For that, random number is generated. For asking here, random.nextDouble will generate the value 0 or 1, and it will be multiplied by 100. Then this double will be converted to cast to integer value. It will be saved to probability problem. Okay, if problem is less than 50, answer is maybe. If problem is less than 30, it will give you answer no. Problem is less than 60, it will give you answer yes. If problem is less than 75, answer later. Problem 98, less than 98, answer soon, and else answer never. Okay, so this switch case, this if else is same, only the difference is we are giving the enum to generate the constants. Okay, this is also same. For no it will print no, for yes it will print yes, and all these values are given to switch the result, and the answers result is given here. Whenever we will call this, answer will be passed to this particular function. Okay, so this is answer. Question dot ask. The question object is created. Question dot ask method, it will return the answer, and this answer will be passed to this result as a result to this method answer. So how to call without the object? So it is declared as static. So directly we can call it like answer question dot ask, answer question dot ask. Every time output will be different. Okay, yes 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 no, soon yes yes no, maybe yes soon soon later. Okay, maybe yes later maybe. Okay, so every time answer is different because we are generating the random number. So in random number it will be calculating our problem, and that problem will be dependent upon random number. Every time random number is new, so problem number is also new, and output is also new. Okay, now we will see the wrapper class example, that is wrap demo. Now this is very simple program. The wrap class integer I object is equal to new integer 100. Okay, so 100 is an integer value, primitive type int. It will be converted to I object, and okay, so you can add the suppress warning. This is the suppress warning for the constructor. Like we have seen, suppress warning is a annotation. Okay, so this is the way we have created the object of class integer and I object dot int value. Why it is suppress warning? Because this is the old way to convert primitive type to wrapper class to primitive type. This is not used nowadays, so it is giving you suppress warning annotation. Okay, but just for the sake of understanding, we have used this program in the theory part also, and now in the practical part also, to understand before Java 5 how it was written. It was written it like in wrapper class name object name is equal to new wrapper class name. In the bracket we are going to pass the value, and this will be converted to I object, and I object dot int value will be stored into value I. Okay, and now it will display the value 100 and 100. It will display 100 because both are equal 100. I is also 100 and I object is also 100. Now the next project, Autobox demo. So autoboxing, how we are performing autoboxing, we are going to see. Okay, same example like in theory part. Integer I object is equal to 100. Here it is not giving us the suppress warning annotation. Why? Because it is the latest method to convert primitive type to integer wrapper class and wrapper class to primitive type. So it is autoboxing, automatically converted to wrapper class, automatically converted to primitive type, and it is also displaying me 100 and 100. So it is very simple example, no need to explain it. I theory explain in a theory part. Okay, so now I will close this project. Then Autobox 2, take an integer parameter and return an integer value. Okay, method parameters and return values, autoboxing and auto unboxing automatically takes place. Okay, so Autobox 2 has one method m. It is having the wrapper class object integer v and it is returning v. Okay, so this is already explained, but still if I am passing here 100, 100 is a primitive type, so it will be written over here. It is automatically converted to wrapper class. Okay, then after calling it will it is returning int. Okay, so returning v will return me the wrapper class object. It will be automatically converted to primitive type. After it is having the primitive type, it is automatically converted to integer, and after integer it is displaying me the value 100. Okay, so you can go through this method, go to this program. Okay, it is very simple program. It will display me the value 100. Okay, Autobox demo 3 we are going to see. Okay, so autoboxing and unboxing inside expression, evaluation of expression. We are going to see ordinal value of I object is I object. Okay, then plus I object. After plus I object, automatically unboxes the I object, performs the increment, and then reboxes the result back. Okay, so plus I object is performed on the integer wrapper class, but it is not possible. Here I object is initialized with 100. So primitive type 100 is assigned. So here it is converted to wrapper class I object. 100 is now wrapper class object. Now for converting or incrementing, what it will do? It will convert it into primitive type int, int. Then it will increment it and it will display, and then it will rebox. And after plus I object, it will display. Then I object is unboxed first of all. So it is 101 plus 101 divided by 3. Okay. So what is 101? 101 divided by 3. It will give me 33.66. Okay. So 33.66 is automatically, this is automatically converted to int. 33.66 is written. So decimal point and 66 is removed since it is an integer. So 101 plus 33, that is 134 will be written. And after expression, it will be displaying me 134. The same expression is evaluated, but result is not revoked. I is equal to I plus I object divided by 3. Okay, so 2 times 134 will be displayed in this case. Original value after plus I object 101 and 2 times 134 is displayed over here. You can go through this program. Sorry. Okay. So now we will see the next example, Autobox demo 4. Now, here I am creating I object, D object 98.6, converting and adding D object plus I object, and after evaluation of expression, total value, that is 198.6, will be displayed. And also here my I object is equal to 2 and switching the value over here. No need to write over like this, dot int value. Okay, no need to write this. It is not required because it will automatically convert this my object to integer representation, that is int representation, and it will switch to 2 and it will display with the result as 2. Okay, so what it will be doing here, first of all 100 will be converted to integer wrapper class, then double wrapper class, its addition is performed, then it is automatically boxed to the D object, double object, and it will be displaying 198.6. Since it is double, it will not remove the decimal point and anything written after the decimal point. Okay. This is Autobox 4. You can go through it. Okay. We will see Autobox demo 5. Okay. Autobox unbox a boolean. and character. Okay, we have seen autobox unbox for integer. Now we will see autobox unbox for boolean, how it is happening. B is auto unboxed if B. So true is evaluated, true is converted into wrapper class B, then it is saved over here. B is true. Okay, then character ch is equal to x, box a character. So every time it is evaluated, it will be first converting this value to primitive type boolean. This is a wrapper class boolean. It will be converting to primitive type boolean, and then it will evaluate the expression. If B is true, then it will display B is true. Now for characters x is stored over here. So box a character automatically to a wrapper class character. Since it is a char, it will be automatically boxed to character class, and since it is a character wrapper class, it will be automatically unboxed to a character representation, that is char. Okay, so you can go through this code. Autobox 5. Now we will run this. B is true, ch2 is x. Okay. These examples are very simple. Okay. No need to worry about it. When you will practice it, you will be understanding it better. Now we will see the annotation examples. Autoboxing is done. Now we will move to the metadata, that is data about data. Annotation. Metadata term is not used nowadays. We use the annotation term. Okay. So whenever you will be calling this, you will be calling this as annotation. So first is metadata demo project. Here I am inputting annotation and reflect. Okay. So these two packages are important. You have to remember this. You have to import it so that your program will run. Then retention policy runtime. So your annotation will be available both at compile time and runtime. Annotation is declared as @interface my annotation, and two parameters are there, string and value. Now in the class meta, we are using this annotation with my method. Annotation example value is initialized with 100. String is initialized with annotation example value is initialized with 100. Then for my method, we are creating the object of meta. Then as usual, we are getting the object of the class, get a class object that represents this class, object.get class. It will be saved in the class. Then c.get method. For which method you have to acquire annotation, the method name is my method. My method I will be passing over here c.get method. This class, this method's annotation I have to acquire. I will be storing this into m, then get annotation for this class. m.get annotation, my annotation dot class. So annotation name is my annotation dot class. Now it will be saved in the my annotation. And to acquire the values in the parameters stored, how to display them? Annotation.string, annotation.value. Why these parameters are passed? Because the names are str and val respectively. So how you will be displaying it? Annotation.string, annotation.value. And if no such method, my method is there, it will be throwing the no such method exception, and it will be caught into this one catch block. Okay, since annotation method cannot have a throw clause, it cannot throw a method. Everything that you will write here will be written only inside the try catch. So any exception in some cases, if there are any exception occurring, those will be caught into catch block, try catch block. So try catch will be recommended all the time, and my method is called, since it is a static, it will be called without using object. Okay, so you can go through this code, how it is written and how it is appearing inside the Eclipse. We have seen the declaration inside theory part, that is PPT. Now we will see how it is appearing inside the Eclipse part. The policy is given in runtime, blue color. You can see primitive types are in red color. Okay. So now we will be seeing the next example of annotation. Sorry, I have not run this. I've run this project. Annotation example 100 is the output of this program. Okay. So we will move to the next one. Now meta 2. Okay. Two parameters. Value 90. Same way we are using like in the previous example. In my annotation, these values are initialized over here. Then object of this class is created. Then object of class is get over here. Then parameter types are specified, which we are passing to annotation string.class, int.class, and in c.get method, which method I have to acquire annotation. This will be saved in method m. Then m.get annotation, annotation name.class. It will be saved in my annotation object, and I will be displaying annotation.string, annotation.value. So in this case, it will display me. This is called like this, my method test comma 10. So this way, this will display me output 2 parameters and 90. Okay. So this way we have understood this program. Okay. Now we will move to the next program, that is metadata demo 3. So there are two annotations. So get annotations method we will be viewing over here. So how to acquire more than one annotation. One is my annotation and second is what annotation. My annotation is having two parameters, string and value. What annotation is having only one parameter, string description. Okay, what description regarding class is annotation test class, and annotation test class string is meta 3, value is initialized with 99. Okay, and what annotation and my annotation for method, my method is initialized like description is equal to an annotation test method, and my annotation string is equal to testing, value is equal to 100. Now object is created as usual. Here I'm directly getting annotations like object.get class.get annotations. It will give me all annotations for this particular class, and those will be saved in annotations. This is get class, you have to note it down. This is not get method. It will give me annotations for get class. Okay, particular class. Then all annotations for meta2 are displayed over here, a new line. After that, object.getClass.get method, and here it is saved, and after that m.get annotations will give me the annotations array for the particular method. So all annotations for my method are stored and displayed over here, and no such method exception is caught in catch block, and my method is called from the public static void main. So now I will run this program. All annotations for meta2, all annotation test class, string meta3 99, then testing value is equal to 100, and annotation test method. This is the output of this program. You can go through this code. So now we will move to the next one. Metadata with default values. Now annotation is created, default value, testing, and 9000 are created. Then its object is created, class object, then object.getClass, getClass.get method, and method.get annotation, and all these strings values are displayed over here, annotation.string, annotation.value. So it will display me testing and 9000. All the remaining stuff is same and easy to understand, so no need to worry about it. Okay, you can go through this code. The only difference is that this line, default testing and default 9000. Okay, all the remaining stuff is same and that we have already explained. Okay, so output is testing and 9000. Now we will move to the next topic, next project, that is marker annotation demo. Now this is a marker annotation. It has no parameters, only opening and closing braces. Curly braces are there. Okay. Marker class is there. Object is created. Object.getClass.get method, my method is stored over here. Is annotation present, my marker.class. So this annotation is present. It's present is sufficient. Its presence is sufficient. I have already explained in the theory part. Okay. So it has no parameters at all, only opening and closing parentheses. And to use that my marker annotation with the method, I have already only used my @my marker. No opening and closing is needed because it is a no parameter marker, that is marker annotation. No parameter annotation, that is marker annotation. And is annotation present method is used to check whether this annotation is there existing in the program or not. So how you will pass it? Method name Method name is my method. Is annotation present my marker dot class. So if this method is having my marker annotation, yes, it is having. I have written like this at the rate my marker. Okay. So I will check it, and if it is there, if it is written over there, it will return me the value like true, and I will display my marker is present. Okay. Otherwise, no such method exception is called. I have called my method. Now I will run this. My marker is present. Okay. So now my marker is not present because I have removed this line using comment. Okay. If it is there, it will give me my marker is present, and in this case it is not present, so it will give me my marker is not present. Okay. So you can go through this code now. I will remove this comment. This was for the sake of understanding. Can go through this code line by line. Annotation and reflect packages are compulsory so that your program will run. You have to understand this. This is a marker annotation. So it is having only opening and closing curly braces. No parameters are there. Then to declare or to use it with your method, you are using @ marker annotation name. No opening and closing parenthesis is needed over here. Then all the remaining stuff is same. Object.getClass.get method, it will be stored in M. Then is annotation present, will check if this annotation is over here or not. If it is having, it will return true, otherwise it will return false. So our exact output is, original output is my marker is present. Okay. And my method is static, so it is called from the main. Okay, so now we will move to the next program. Single member annotation demo. Now single member has only single member. This must be a value. Okay. And if it is having more than one member, it should have a default value. Okay. So here one interface, one annotation is created. Single member annotation. My single. It has one value into value. It is directly passed as 100. No need to write my single value is equal to 100. If you are passing directly 100, since it is having only one value, it will be directly initialized with the 100. So here value will be 100. Now my method, object.getClass.my method, it will be written over here. M.get annotation, annotation name.class, it will be stored over here my single annotation. Then annotation dot value, it will display me 100 because I am passing here 100 over here. Okay. So here I am calling the my method. So in this way, we have understood the single member annotation. I can display the value as 100 over here. Okay. So you can go through this code also. Every time we are giving the retention policy runtime, you have to understand this. And all the remaining stuff that is inbuilt annotations like suppress warning, deprecated, override, and inherited, and all that stuff will be we will be learning throughout whenever you are coding by your own, in your own Eclipse or your own IntelliJ IDEA projects. You will be understanding these annotations by your own. Okay. So its theory I have already explained. Default or inbuilt annotations theory I have already explained in a theory part. So only thing you have to do is you have to practice more and more. Whenever you will be coming to that inbuilt annotations, you will be understanding it better. Okay. So this way we have completed with the practical part, enumeration, autoboxing and annotations practical. In the next upcoming, we will be viewing with the input output in Java theory. Okay. So meet you in the next session. Thank you so much.